So doing the practice test, remember, this is just like the real test, only the answers have been changed to protect, the numbers have been changed to protect the answers. But otherwise, it's essentially the same thing. Number one, determine whether the function y equals 16 times 3/7 x is decay, and list the corresponding growth or decay, list the corresponding factor. This determines right here whether it's growth or decay. If it's between 0 and 1, it's decay. If it's greater than 1, it's growth. Okay. So this one's decay. This is less than 1. And my decay factor is C7. What I'm raising to the power determines whether or not it's growth or decay. For the next one, list each the following as growth or decay. So this number here is less than 1, so it's decay. This number is here more than 1, so it's growth. This one here is less than 1, so it's decay. Yes?
If it was like 2 over 2 or 1 exactly, would you
There is no growth or decay.
Yeah, like static.
Because it's not changing, yeah. So it's with exponentials. Exponentials where your base is 1, we ignore those because they don't change. It has to be something other than 1. It has to be greater than 0. Okay, so this one, the next one, you deposit into $1,200 into mutual funds that is projected to earn 3.2% interest annually. How much will you have in your account 6 years later? Please answer to the whole dollar. This is the formula you need to use. The amount that we have is equal to the amount we start with times 1 plus or minus the rate, whether it's growth or decay, to the time t. Whole dollar amount, no decimals. Answer the question the way it's asked to be told. So I set it up. The amount I'm looking for is equal to 1,200, 1 plus 0.032 to the 6th power. This one you don't need to use logs because you're not solving, you're trying to figure out the amount. Do remember, order of operations. You do this part first before you multiply by 1,200. Exponents before multiplication. Okay, that is the most common error on this one because it's relatively simple. Is students not doing the proper order. And you round it off and you get 1450. Rounding it off to the nearest dollar. Next one does the same thing. Same idea. This is the amount I start with. That's my rate. It says write an exponential model to solve it. So how much do I have if I start with 85 mice and it's growing at a rate of 5%? Doesn't give me the time, doesn't give me the final amount. I have 2 variables, 1 equation. I can't actually solve this. But it doesn't ask me to. It says to write an exponential function that models it. So the only thing I'm going to do is simplify it as best I can. And that's the best I can do. I have 2 variables in 1 equation. You can't solve if you have more variables than you have equations. I've got 2 missing variables, 1 equation I can't solve. The best I can do is write the equation out and simplify it down. And that's all you're being asked to do anyways. Okay, read the questions carefully. Write the equation in exponential form. This is looping it. So remember the base of your logarithm is the base of your exponent. So it's 5 to the negative 3 is equal to 1 over 125. Number 6, solve. And I can kind of solve it any way I want to solve it. What I would do on this one is I would get the same base on this one, rewrite 127. So I have 3 times x minus 6 is equal to 3 to the negative 3 to the x minus 1 power. Which means I have 3 to the x minus 6 is equal to 3 to the negative 3x plus 3. Bases are the same. The exponents have to be equal. X minus 6 is equal to negative 3x plus 3. Add 3x. Add 6. And I get 4x equals 9. So x equals 9 fourths. And I think we have discussed the fact that yes, fractions are just fine. This one, you need to loop it. So I get 4 to the x is equal to 1,024. And what you have to do is figure out what power of 4 is 1,024. Okay, that's what you want to do here. Now, you can take the log of both sides after rewriting it. That will also work. But at this point, I would just do it by 4s. And you got your calculators. I know that 4 cubed is 64. So I'm going to try 4 to the 4th and see. No, 4 to the 4th is 256. 4 to the 5th power. There you go. 4 to the 5th power. Just take your calculator and try it. See if you can find out what power 4 your calculator. That way you're not multiplying by longhand. You don't have to. Use the tools. Okay, yes. So it's 4 to the 5th power. X equals 5. If you took the log of both sides, you would end up with the same thing in the long run. Okay. Number 8, solve for x. My first step here is actually divide both sides by 4. And I get x to the negative 4/3 is equal to 16. Now I have a couple of choices because I don't specify how to solve it. If I do by what we learned in that section, what I would need to do is rewrite 16 as some negative 4/3 power to give me whatever 16 is, some number to that power. But we did other ways of solving, and I'm okay if I don't specify. Use whatever works best. Frankly, the one that works best on this is reciprocal powers. Multiply by the reciprocal. The reciprocal of negative 4/3 is negative 3/4. Negative 4/3 times negative 3/4 gives me x to the 1st. And then I take 16 to the negative 3/4 power. The negative means I have 1 over. The 4th root of 16 is 2. 2 cubed gives me 8. So I get 1/8. The denominator means I take the root. The numerator means I take the power. The 4th root of 16 is 2. 2 cubed is 8. Expand using the properties of logarithms. First thing I need to do is rewrite the cube root of x. Well, it's not the first thing I need to do. Actually, let's split this up first. So I have multiplication here. So that's log base 2 of 9 plus the log base 2 of the cube root of x. That's not adequate. Yes?
We're going to do 1/3 log.
Right, so what I need, yeah, I'm doing it in steps. So what I need to do is rewrite this as a power. Log base 2 of 9 plus log base 2 of x to the 1/3, and then bring the power down out in front. So I get log base 2 of 9 plus 1/3 log base 2 of x, and that's my final answer. Should be no exponents, no roots, and split up as much as possible. Okay, that's the rules. On this one here, I want to combine it into one logarithm. My first step is to bring all my powers up. So I get log base 2 of x to the 7th plus log base 2 of y squared minus log base 2 of 4y quantity squared. And this is important. I'm squaring the entire 4y. Now I can combine them up into one logarithm. Log base 2, x to the 7th, y squared. I take 4y and square it to get 16y squared. But what happens to my y squareds? They cancel out. So I get log base 2 of x to the 7th over 16. Because the y squares cancel out. Pretty much most common mistake on this one would be not squaring the 4. Remember, it's 4y quantity squared.
The y squared.
Use the properties of logarithms to evaluate, simplify your answer as a number, not a logarithm. It should tell you what you should have for your answer. You should have a single numerical answer. What I would do on this is start bringing them together as one. Okay. So I have, this is log base 4 of 8 times 2 times 32 all over 2. Right? Because anything that's added, I multiply. Anything that's subtracted, I divide. Well, if you look at this, the 2's cancel. Okay, your 2's cancel. So you get 8 times 32. So I get log base 4 of 256. And then what we did on these problems is you get log base 4 of 4 to some power. In this case, 256 is 4 to the 4th. Bring the power down out in front. 4 log base 4 of 4. Well, log base 4 of 4 is 1. So my answer is 4.
You did it so complicated.
Yeah. Rules of logarithms. Combine them up into one logarithm. What are the rules of logarithms? When you have things that are added, you multiply them. When you have things that subtract, you divide. That's not that hard. That's one step that takes us to here. And then you want to have 4 to some power. Use your calculator. Take 4 to some power till you get 256. You got it. You're not doing it by longhand like I had to. Use your freaking calculator. It's easy. It's not that hard. Yes, it's confusing. Told you it would be. And the day before the test, you're like, oh my God, it's hard? Yeah. Who said it was going to be hard? I did.
Will it be similar to this?
What always all the chapter tests are. Yes.
It'll be.
Okay. Bring the power up. Now, this one also looks like it's nasty, but it really isn't going to be that hard. So you end up log base 3 of 27 squared divided by 9. So you get log base 3, and then you do that on your calculator. Take 27, and you square it. Divide by 9, and you get 81. It's not that hard. You have a wonderful tool that saves you the headache of the arithmetic. 81. It's 3 to the 4th. Certain powers you should start knowing by now. We've done them enough. They should be recognizable to you. Even if you don't know what power of 3 that is, you should know, oh, that's a power of 3. And be able to figure that out. Bring the power down in front. 4 log base 3 of 3. And at the base of the logarithm, and when I'm taking the logarithm up, are the same thing. That's 1. So once again, you get 4. Okay. Solving them. All kinds of different ways to do it. When you see logarithms, the first thing you should try to do is if you have logs on both sides or just have logs that are on one side, combine them up into one. Do that first. Log base 3 of 4 minus x, log base 3 of 4. That's log base 3 of 4 times x minus 4 equal to 3. If I have a log on one side and no logs on the other, loop it. Rewrite it as an exponential. 3 cubed, and then distribute here, 4x minus 16. And 3 cubed is 27. So I add 16 to both sides. 43 is equal to 4x. Divide by 4. X equals 43 over 4. Ooh, we got a fraction. Deal with it. Okay, so the next one. There are more than one way to solve, but you want to try the best one. 6 to the 3x is equal to 125. If I have the power in the exponent, I have a problem like this where I have a number raised to a variable equal to a number. What I want to do is write them as the same base. Can I write 125 as a power of 6? No, I can't. So if I can't do that, then you take the log of both sides. Okay. Bring down the power in front. So I get 3x. Log of 6 is equal to the log of 125. Divide both sides by 3 log 6. So I get x is equal to the log of 125 over 3 log 6. Pull out your calculator. And you get 0.898. 3 decimal places. Okay. So this one's a little goofy. Solve the problem. So I can't rewrite x as some power of 3. I have the log of both sides. I have a log on one side. So what do I need to do? I need to loop this. I have a log on one side and something on the other and a variable involved. I need to loop it. That's the first thing I need to do is rewrite this as an exponential. So I get 3 to the x is equal to 84.6. Can I write 84.6 as a power of 3? Not easily. So when I have this situation, which is just like the last one, I take the log of both sides. And I bring the power down out front, so I get x log 3 is equal to the log of 84.6. Divide both sides by the log of 3. X equals the log of 84.6 over the log of 3. X equals and I get 4.040. Or 0.040. 4.039. It's a 395. Cut it off around it, either one. Okay, the population of Sacramento is about 470,000 people. If it is forecasted to decline at a rate of approximately 3.25% annually, yearly for those of you who don't know what annually means, and how many years will it take for the population to reach less than 400,000 people? State your answer in whole years, not decimals. So, I want to get to 400,000. I'm going to do this in hundreds of thousands. So I want to get to 400,000, starting with 4,700,000. And I'm declining, so it's 1 minus 0.0325 to the t. And I want to figure out what t is. Okay, same formula we used for growth. Okay, it's one we did on one of the first days that you have to know. Okay. Divide both sides by 4.7. And 1. And you get 0.85106.3 blah 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 equals 0.965 to the t. Take the log of both sides. Bring the power down out in front. T log of 0.965 is equal to the log of 0.851063. Divide both sides by the log of 0.965. T equals 4.526. But what does it ask for?
Whole year.
It asks for whole years. When will it get to, at what point, after what point will it get to 500?
5 years.
So, yeah. How many years will it take for the population to reach less than that?
5 years.
Stop. Okay. At this point here, that's exactly 400. If this was 4.01 and you answered 4, it would be wrong. You have to round up because it says, when am I going to get less than 400,000? So if it's more than 4, you have to round to 5, no matter how close to 4 it actually is. So if you get a number that's like 4.000001, well, that means that 4 years is still giving you more than 400,000. So, in what nearest whole year is it going to be less than that? In 5 years. It'll actually take less than 5 years, but that's the nearest whole year to get there. Okay? So you have to understand, it doesn't matter what the number is. Unless you come up with a whole number, you're going to round up. Because if you get one that's less and you round down, you're going to be wrong. Because at the time you say it is, it won't be less than 400,000 or whatever. Okay. 17. Performance task. Boy, you better get the first one right. Plot those 3 points and draw a curve through those 3 points. 0, 1, 1, 4, and 216 is somewhere up here. And we did graphs of exponentials. You need to know that's what that looks like. Is this growth or decay? Is it getting larger or smaller as we go from left to right? Is it going up or going down? It's going up. It's growth. Okay. The points are getting larger. It's growth. Even if you graph this incorrectly by plotting the points and making a straight line through them, which would be wrong, because it's not what an exponential looks like, you should still understand that that's growth because it's getting larger, not smaller. If it's getting smaller, then it's decay. Okay. Next one, fill in the points. Well, it gives you one of them. I mean, 2 to the 2 of 16 here. I mean, really. I mean, that's not that hard. Expect at least that much. Okay. And then you got to figure out what the pattern is. I'm going up by 1 each time here, but I'm not going up by the same amount each time. How do I get from 1 to each one? And you got to realize it's an exponential. What have we been talking about? It's either logarithms or exponentials. I'm not going to make you plot logarithms by hand. So I'm going to make you plot exponentials, which means you're taking some number, raising it to a power. Let's see. Anything to the 0 power is 1, though that's not helpful. But I have something to the first power is equal to 4, and something to the second power is equal to 16. What number do I take the first power? Do I get 4? And then I take the second power, I get 16. That's 4. So I'm going to take it to the third power and get 64. Once again, I'm going to have some number to the x power. What number is that? It's 4 from the table. Anything to the 0 power is 1. So x being 0 doesn't help. But the other ones ought to tell you exactly what's going on with it.